This is a little demo of a hobby operating system I'm writing called Kitsune OS. It runs on the Raspberry Pi, and I've got the Raspberry Pi hooked up to capture cards, so that's what you'll be seeing here on the left. And I've got it connected to my computer through the GPIO pins, connected to like a little USB converter. I think it's like pins 14 and 15 for the UART serial port. So that's what we're going to do here. We're going to connect to those as soon as we power it on. So let's get this started. So now we're listening to those two GPIO pins for the serial port. I'm going to power it on now. Here we go. Just a moment here. We should see our little, there we go. So it says, hello, this is register 0, 1, and 2. This is going to be our device tree address. And that's probably the next thing I'm going to work on is a device tree parser, because right now I'm just hand coding all of the addresses and configuration. So once you're in, this is basically your terminal for now, since I don't have USB or keyboard or anything like that working. This is all being driven through the serial device. So I issue commands by hitting different numbers on the keyboard, which sends it through the serial port. So if I hit 1, it just gives me a little message. If I hit 2, it triggers a software interrupt, and right now my interrupt handler pretty much just says software interrupt. Hitting number 3 tells you what mode the processor's in, and right now this is just, very basic single-threaded, nothing fancy going on here. So it's only the first processor running, and it's running in processor mode hex 13, which is system mode, I believe. I forget the name of it. Service mode, something like that. It's kind of like the default mode for an operating system. This is kind of fun. If I hit key 4, it does a little performance test. It checks the performance counter, which is, I think, is like the clock cycle counter, and it just runs that 6 times. And this is the result it gets, and then it just gets these are the differences between each of them, so you can see it's pretty consistent. Each call to read that register is 9 clock cycles, what it seems to be. And then I think I've also got some frame buffer tests. So as you can see over here, we've got the default Kitsune logo. If I hit key 6, it's going to draw a little square on the screen, very simple. If I hit key 7, it kind of draws a quarter of a circle. And that was not an animation, by the way. It was that slow because that's how slow it is writing to the frame buffer. I haven't gotten the video core stuff figured out yet. So this is very basic. You're just writing pixel data to a spot in memory, and it shows up on your screen. If you hit 8, you get a little Spider-Man. And then 9 will redraw the logo, and then hitting 0 will clear out the frame buffer. So I'll put a few of those back. See, it has to wait after it renders every one. So it's quite slow. And then there's a couple more things. If I want to draw that little quarter circle in a different color, I have this little entry mode where I can type in different colors here. You can hit backspace or type stuff in. So I can do red, make a red stripe, or I can do purple stripe. And also, there's one other thing. If you look in the ARM Architectural Reference Manual, the ARM as they call it, it's got a lot of references for these different coprocessor registers. So one of them I talked about earlier was this performance monitors cycle count register. And typically you go into your code and put this little line of this assembly call here. But I actually kind of wrote this little instruction generator. So you type in the coprocessor number. So here it's going to be 15. So I'll hit F. And then opcode, the next opcode here is 0. So I punch in a 0. and then CRN is going to be 9, and then CRM is going to be 13, so it's in hex, so I'll hit D, and then the last opcode is 0, and then it spits out this little guy, which is actually the instruction, and then if I hit exclamation mark, it's going to call that instruction and store the result in register 0. And there's the value of the performance counter register. And as you can see, if I just keep calling it over and over again by holding down that key, it's ticking up at a pretty consistent rate. It's not the full clock speed. I haven't figured out how to turn up the clock on this yet, so I'm assuming this is just the base clock speed. But yeah, pretty cool.